1, notes part 1 corresponds with worksheet A and B. Worksheet A and B. So as we get through these notes, you're going to realize that we hit notes part 2, and notes part 2 correspond with worksheet C. So we're not touching worksheet C, and we're not touching notes part 2 today. No way, no how. Okay? Hopefully we can get all of notes part 1 done today, in which case you can do worksheet A and B. Okay? Seeing as I don't know how far we'll get, but all of it's here in one packet. Okay? So don't lose your packet. We're for sure going to finish it. I just don't know how far we'll get in one sitting. Okay? So what I had you do on that circuit is a fantastic warm-up for what we're doing here. This is going to be solving exponential and logarithmic equations. Okay? For the purposes of just kind of zooming and trying to get going, I think you guys understand pretty well how we can convert between exponential and logarithmic form. We understand that if I take my base to the power of C, I get A. Right? You just did that. That's what you were working on in this paper. So my base to the power of C gives me A. That's how I convert between one equation and the other, one form and the other. Always remember the log equals the exponent. The log equals the exponent. So the base to the power. There are some power properties, product property, quotient property. We've been through those. Okay, I think you guys are really familiar with those based on the fact that you did the puzzle yesterday in 10 minutes. So if you need review of that stuff, go back and look. I think we're ready to go on. Okay. So in the middle of the page, it says equations with only one log or only one exponential function can be solved by converting between exponential and logarithmic form. Understanding that those are inverses of each other, we can solve using those properties. So step 1 here is going to be isolate the exponential or logarithmic expression on one side of the equation. You're going to isolate that one piece. And then it says write the equation in the alternate form. That's what you were doing. And sometimes you do it in your brain. Right? If I see log base 2 of 8 to solve, I'm converting and I'm saying 2 to what power makes 8? And you know it's 3. Right? So convert to the other form and you can solve it. Solve for the variable. Simplify and or round answer as directed. Okay? So on this whole page and on the homework, there is no calculator. Okay? So we may be leaving answers in exact form. That's what this says right here. Leave your answers in exact form. So we're going to go as far as we can, and then we're going to put a box around it. I don't know what e to the 25th is. I don't care. I don't need to know that decimal. I'm going to say x equals e to the 25th, and I'm going to be done. Okay? So number A, or letter A, example 1. Solve the following equation. So what we want to do first is isolate the exponent. Get that piece by itself. So add 2 to both sides. Okay, so that's going to be 4 to the x equals 9. 4 to what makes 9? I don't know. So we're just going to rewrite it in logarithmic form. What's my base? 4. So log base 4 of 9 is x. Did we solve for x? Yes, that's a constant. That's a number. We're done. Okay, no calculators. So at that point, we're satisfied. Go on to B. 2 to the x plus 3 plus 5 is 26. So what are we going to do here? Move the 5. So 2 to the x plus 3 is 21. Now let's divide by 2 on both sides. Good. Frankie looked at me with bad eyebrows. Right. Do not divide by 2. That's not how we handle this. I'm trying to set you up for a trap, right? No, don't divide by 2. Let's do a logarithm. Log base 2, right? My base is 2 of 21 is x plus 3. Now iso x.
Can you subtract the 3 from the 21?
No, just subtract the 3 from the whole logarithm.
Can you put the 3 at the negative 3 at the beginning?
You could put negative 3 plus log base 2 of 21, but you can't multiply it. So I would put log base 2 of 21 minus 3 equal to x. Okay, it's not negative 3 times it though.
Yeah.
It would be negative 3 plus. Okay. Yeah? Everybody all right? How about here? Minus 3, she says, with authority, and she's right. So negative 7 minus 3 is negative 10 equal to negative 4 e to the x. Now we got to divide off the negative 4. Do you see the difference? Earlier I tried to get you to divide by 2, and there wouldn't be anything left. You can't do that. But here, we do have to divide by that negative 4. Which makes what? 10/4, better known as 5 halves. So 5 halves is e to the x. How do I get rid of e? Natural log. Okay, so this would be log base e to the, or of 5 halves is x. Log base e of 5 halves is x. And instead of writing log base e, I call it natural log of 5 halves is x. Done. Go. We're good. Y'all agree? Are y'all okay with this? Yes. Such a very smart class. No matter how many days I'm frustrated with y'all, you just remember, Armenta, we're brilliant. Never ever frustrated with y'all. You're dang smart.
Nikki's on the work.
Okay, so this is going to go the other way. We're going to do the same thing. Leave your answers in exact form. But these are all logs that we're going to turn into powers, exponents of some sort, right? All right, so we've got 2 log base 3 of x plus 3 plus 4 is 10. We want to ISO the log. Not first. PEMDAS backwards. Move the 4 first. So 2 log base 3 of x plus 3 is 6. Now we can divide it by 2. Sorry. So log base 3 of x plus 3 is 3. So now we want to write it in a power because I can't break into that x plus 3 business. So how do we write it? 3 to the, say it louder. 3 to the 3rd power, right? Base to the power equals the argument. X plus 3. What is 3 to the 3rd? No? 27. Don't say 9. It's not 3 times 3. It's 3 to the 3rd. 27 is x plus 3. Now what?
24.
Good.
So 24 is equal to that.
Yes. X is 24. You like that? That's okay? Okay, letter B. Truett says, now we subtract the 2 first.
What is 4 to the 5?
Agreed. Subtract the 2 first. So log base 5 of 2x minus 1 is 2. So what? It's not 2 to the 5th. It's 5 to the 2nd. Back up, Truett. It's not 2 to the 5th. It's 5 to the 2nd. Okay. 5 to the 2nd is 25 would be 2x minus 1. So we're going to...
Oh, I said 4 minus 2 is 4.
I got 13. Good? Yes? Yes. Megan's good. Jimena? Good. Okay. All right, letter C. Last thing. Last one of these. Letter C. Multiply by 5, he yells with authority, and he's right. Multiply by 5. So we can cancel the 5.
E to the 5th.
Okay. Truett's onto things over here. So we have natural log of 2 minus x equals 5. And he says that is e to the 5th would be 2 minus x. So now what?
Plus 2.
Nope, not plus 2.
Divided by negative.
Minus 2.
What?
E to the 5th minus 2.
Then divided by.
Then divide by negative 1.
I was.
Womp womp. All right, so simplified, I like x equals 2 minus e to the 5th.
Easy.
Yeah, they're puzzles. Not puzzles like we worked yesterday, but still puzzles. I like these. Good? Ready to go on? Okay. Moving on. Did I go too fast? Yes?
Wait, so it was 5 to the second. So you take the base and raise it to the equal.
Right. Base is the base. Base is the base.
Gotcha.
I would say Megan Trainor, and Ruth wants to throw things. So no Megan Trainor, but the base is the base. It is not about the base. The base. The base. Okay, so what happens if I have more than one logarithm? Okay, the biggest thing that you need to know here, important note number 1, we need to check for extraneous solutions. Okay, I can't log a negative number. Cannot log a negative number because the logarithm's asymptotic at 0. Undefined over yonder. Okay, can't log a negative number. So we're going to check the domain. We're going to make sure that we're not trying to do that. Number 2, if we simplify, we can finish by setting x equal to y. No, that's not the second thing. Important number 2. This is number 2. When you have multiple logarithms in one side of the equation, you don't just get to drop the logs from everything and carry on. You've got to use properties of logarithms to condense them. Okay, so if they're adding, that means we're going to be multiplying. If they're subtracting, that means we're going to be dividing. We've got to use those properties to simplify. You can't just cancel all the logs and drop them from everywhere and decide, hey, everything's got a log, I'm going to throw it out. Does that make sense? Sort of. Okay, so first, check for extraneous solutions. What you've got to make sure is that your arguments are always greater than 0. So is 3 greater than 0?
Yeah.
So we're not going to have to worry about that one. How about x plus 4? When might that be less than 0?
If it's a horizontal translation.
If x is less than, x has got to be greater than negative 4. Would you agree with that? Okay, x has got to be greater than negative 4. How about this one? 5x minus 2, set that equal to 0. Set it greater than 0. So x, in this case, has got to be greater than 2/5. So what's the lowest thing that x can be here? 2/5. So I don't need to say x must be greater than negative 4 because it's got to be greater than 2/5. Can you see what we're saying? So your domain here, your domain is going to be x greater than 2/5. And as long as your answer shows greater than 2/5, it's acceptable. Okay? So we're not ready to solve just yet. We've got 2 logarithms. We don't just get to go in here and cancel the logs. Okay? That breaks my heart. Instead, we've got to consolidate logarithms using those properties that say what? If I'm adding, they're multiplying the argument. So what should be the case is that log base 10 of 3 times x plus 4 is equal to log of 5x minus 2. Once you're down to a single logarithm on both sides, you can say if the log bases are the same, then the arguments must be equal. So then you can drop the log. And we can say 3 times x plus 4 must equal 5x minus 2.
Oh, because they're equal.
Because they're both base 10. Oh, yes, because they're the same. They're equal. Now solve for x.
Oh no.
I got 7.
C.
Yeah?
What if you got 5?
I add instead of subtract sometimes, you know? It happens.
What if you got 5?
Oh no.
That was 2 problems in a row, but you know.
How did you do
What
that?
if you got 5?
You have X on both sides.
Letters left, numbers right. Stand up, sit down, fight, fight, fight. I made y'all do this before. Letters left, numbers right. Stand up, sit down,
you can
fight, fight, fight.
distribute. I forgot about that.
What was the last one? Fight.
Wait, so X can be 0?
Could be.
But it can't. Because it's asymptotic. But it can. I'm lost.
This is shifted.
No, I'm just talking about like in the number in general.
No. Greater than 0. Greater than 0.
Unless it has like that plus 1. Then, okay.
Because it would be shifted.
Right.
Okay, so letter B. Checking our domain first. In this case, x should be greater than -1. In this case, x should be greater than 5/3. In this case, 7's greater than 0, so we don't have to worry about it. So we need x to be greater than, the biggest number here is 5/3. As long as x is greater than 5/3, we're good. That's our domain.
How did you get that?
We set each argument greater than 0 and solved. Greater than 0. So x plus 1 must be greater than 0. X has got to be greater than -1. This one, x has got to be greater than 5/3. Well, if a number is greater than 5/3, it's automatically greater than -1. So I don't need this one. I need this one, right? That's my overall domain. So handle the biggest of your problems, right? Now, the natural logs are being subtracted. So what does that mean about my arguments? They're over each other. They're being divided. So I have natural log of x plus 1 divided by 3x minus 5 equal to natural log of 7. Not just 7, but the natural log of 7. So now I have the natural log on both sides, which means my bases are the same. They're both E. So my arguments must be equal. Yeah? So you can set your arguments up and solve for x. How am I going to solve for x here? Multiply by that denominator on both sides. Make sure that you do what? What am I about to say? Distribute.
I think I read it.
Got 36/20ths? 9/5.
I got 34.
When you did -35 minus 1, did you dig a deeper hole?
No.
Sorry.
No, because I had x plus 1. So it would have been minus.
We good here?
No.
Do we need to back up?
You're good.
Okay.
What did that simplify to again?
9/5, which is greater than 5/3. I made them have common denominators to be sure. Okay, how about this one?
Multiplying.
They're multiplying. So log base 3 of x plus 2 times x minus 3 should be equal to log base 3 of 14. What about our domain? Got to check that. X is greater than 3. Because x has got to be bigger than negative 2 in the first one, and x has got to be greater than 3 in the second one. So x greater than 3 is going to be the rule that we go by.
Now would you factor that to get your x squared and such?
FOIL it out.
Yeah.
Plus 2x minus 3x makes minus 1x in the middle.
Minus 6. Where did 20 come from?
Move the 14, set it equal to 0. 14 on this side.
Oh, wait, there's. Okay, hold on.
Do you square root the whole thing or just x?
Huh?
Do you square root the whole thing or just x?
And then square root x. I'm factoring it. I set the quadratic equal to 0. Factors of negative 20 that make negative 1. X minus 5 and x plus 4. So x equals 5 and x equals negative 4. And negative 4 gets the hiatus because it is not greater than 3. We say to you, boo.
Negative 5.
Oh. Do we have a pickle?
Yeah, we don't like the
X divided by 3.
Where are you? You're on this one? Okay. What's your domain, David?
Wait, so what are you doing if you have a 5 and a 4?
X greater than
Oh.
0.
Oh, because our domain.
Because it's x. It's not 1, it's x. So your argument's got to be greater than 0. And your argument in this case is x. 3 is always greater than 0. On the right side, though, that 2, that's a pickle. Because Ruth was saying we got ourselves a pickle, and she weren't wrong. It's got to be natural log equals natural log, or you can't just drop your arguments. So we need to rewrite that 2 as a natural log of something. Before I do that, I want to go ahead and consolidate this natural log x minus natural log 3. Yeah, so I'm okay with us going ahead and saying natural log of x over 3. But on this left side, if it was a 2 left over, then that means it had to be what? We're in natural log, so we're in base
1.
E. Base E.
Wait, what?
So what was it? It must have been natural log of e to the second. In order for there to have been a 2 left over, it had to be natural log of e to the second. Because what we're saying here is log base e of e to the second would have left me 2. And you see how that's a 2 right there? A lonely little 2?
So you couldn't, like, wouldn't that simplify? Could you not just leave it as x over 3 equals 2?
No.
You'd have to leave it as e to the 2.
E to the second. Yeah, because you can't set your argument equal to 2. 2 is not the argument. The argument was e to the second.
But it's one of those like hidden things.
Uh-huh.
Like it was with the 3 plus.
Because when I first worked this, I got x equals 6. And then I checked the solution, and it ain't 6. So in order to set them equal, I've got to be setting arguments equal to one another. And the argument, if the remaining piece was 2, then the argument was e squared.
3x equals 3.
Yes. X equals 3 e to the second. Which is greater than 0.
Yeah.
It's not 6. That's 12 point something.
So that'd be 3 e to the second. Or 3 times e to the second.
Is that it for now?
No, there's a whole nother page.
Oh, nice.
Nice.
That we have to do in 10 minutes.
That we have to do in 10 minutes. There are only 10 minutes left. I'm trying to see here. I know. Okay, listen. Listen, young children whom I absolutely love. You are for sure able to do all of worksheet A. I will allow us to stop right here. You can do worksheet A. We'll pick up here on Monday. Okay? And then we'll finish this part, and then you can do worksheet B. If you're adventurous, you could do worksheet B. But I really think that you can do all of worksheet A at this point. I would finish the circuit as well. I think the circuit's great practice. Okay.
Show you some of my homework.
During second period Monday. Show it to me Monday. All right, so we're finishing this page. We've got example 4. It says solve the following equations. We're in the same train of thought here. Same mindset. Check for extraneous solutions. So I'm checking, making sure. What's my domain on this first one? Yes, x has got to be greater than, greater than 0 first.
Why? Because of the x in the parentheses?
Because of the x in parentheses. So x is greater than 0, x is greater than -7. You're going to pick the bigger one. As long as we're bigger than 0, we're bigger than -7, right? Okay. So then we want to consolidate the logarithm, right? So that's going to be log base 4 of x minus 3 log base 4 of 2.
That's gonna
That'd be 2 to the third, and they're subtracting. Right, so they rewrite as log base 4 of x over 8. Good. Is equal to log base 4 of x plus 7. So now that your bases are equal, you can set your arguments equal to one another.
Oh, no, subtract x. But then that gives you... No, because you'll factor it will give you 8x, you'll be -7.
Why do you have a -7?
The -7x in the
Oh, okay.
Yeah. Wait, what's 8 times 7?
50. Yes.
56 divided by...
Right there. 8x plus 56.
Yeah. Be -8. Yeah.
So -7x equals 56.
Divided by -7 will give you -8.
So x is -8. Agreed. Can that happen?
No.
Because x has got to be greater than 0. So your answer here is going to be no solution. No worky. Okay. Domain on the next one. Greater than 0. X greater than 7/2. I think this is going to win. 3.5 is bigger than 0. So we're kind of, again, doing the same thing. And this is going to be plus, though. So log of... Yeah, that's a 3 on there. So 2 cubed times x. Can we go 8x? Equals log base 10 of 2x minus 7. So now I can drop the logs. I'm going to change colors because I don't like red. 8x is equal to 2x minus 7.
Okay, so now you minus 2x and 6x. -7, 6. Which is too small, it's not solution.
Too small. No solution.
Like, for the last 3 or 4 problems, I've added instead of subtracted when around moving.
I can't help that.
I can't either. I did it again right now.
Okay, so example 5 says, let f of x be this whatever, and let g of x be that whatever. Find all the values of x where the graphs of f and g intersect. So what are we doing? Set them equal to one another. So we're setting f of x, which is natural log of x plus 10 minus natural log of x, equal to g of x, which is natural log of x plus 3. Everything's got a natural log. Should we just cross them out and move on?
No, you gotta.
Okay.
Oh,
What's the
wait.
domain here?
Would the x's cancel out and that just be 1/10?
No.
No. So it'd still just be x plus 10.
Over x. Yeah. X greater than negative 10. X greater than 0. X greater than negative 3. We want to pick the greatest of those. So
why wouldn't you?
hey, we can barely hear over here. Y'all remember that we're still recording and we're still working. Okay? Thanks and giggle. What now?
Why don't you cancel the x?
I'll show you in just a second. X is greater than 0. We've got x plus 10 over x, the natural log of this. Yeah, because the 10 is not also having an x in there. Okay? Equal to x plus 3, or the natural log of x plus 3. Right? So now that x plus 10 over x is equal to x plus 3.
So you multiply it times x, which would be x.
Multiply both sides by x.
You just subtract x.
X squared plus 3x. Yeah, set it all equal to 0.
Oh, no, you gotta set equal to 0.
Yeah, so I would actually, I'm moving right now my 3x's, and I'm going to back up on that. I don't like it. I'm going to go everything to the right.
So what would that be? I only know.
I'm going to have x squared plus 2x minus 10 equals 0.
X squared minus 2x. You know what I mean? There's something.
It's a positive 3x. So we're going to subtract x.
No, it would be a positive 2.
X squared plus 2x minus 10.
X squared. Okay,
Yeah,
so what would
you're going to have to quadratic formula here. You want me to tell you the answers?
negative b plus or minus?
So the answers we get x is plus or negative 1 after you quadratic formula. Okay, so the quadratic formula, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Thank you. After you do that, and we'll trust that you can do that, you get negative 1 plus or minus square root 11. X is supposed to be greater than 0. So you have to choose x equals negative 1 plus square root 11. Then negative 1 doesn't work. Okay? Okay. There's a few more examples here. It's probably going to take us about 10 minutes. Is that okay?
Yeah.
Are y'all sure?
Yeah.
Okay.
Dylan texted me back. She said okay.
Okay. All right, so example 6, it's the same thing. In the xy plane, what are all the x coordinates? Where the points of intersections of h and k. So if I'm finding where h and k intersect, I'm finding where
They're equal to each
h and k are equal to each other. Okay, so it's the same process here. So log base 3 of 2x minus 3 plus log base 3 of x plus 4 equals log base 3 of 8x plus 2. And I'm really thankful that they all have the same base.
So are we ever gonna get it to like?
I don't think so. You could. I mean, you could change the base, right? That's that conversion that we talked about. But I think that they're not going to make you do that.
I don't even remember it, dude.
Okay, fair. So let's do domain first. Domain on this one X must be greater than 3 halves. X must be greater than
Negative 4.
-4.
And then
X must be greater than
negative 8 halves, which would be negative 4.
1/4.
4.
2 divided by 8.
Oh, yeah.
So I think 3 halves wins here. X greater than 3 halves. As long as we're greater than 3 halves, we ought to be fine. So because these are adding, we can multiply these arguments.
Equal.
See ya. Have a good day.
You too?
Bye. Secret.
See ya.
Yeah.
2x squared minus 3x plus 8x
Negative 3x.
plus
And
5x.
then negative 14. So 2x squared minus 3x minus 14. So negative 28 equals 3. Oh, where did the 5 come from? Oh, wait, no, I had a 5.
Because it's.
Yeah, I subtracted 2.
Wait, did you have 2x minus 3x minus 14?
Yeah,
Okay.
I think I'm a step behind Joel.
Yeah.
So factors of negative 28 that make negative 3,
I feel like there's a 7.
4 and negative 7. 4 and negative 7, so 2x squared plus 4x minus 7x minus 14.
2x squared plus. No, it'd be minus 7x. Right? No, it'd be plus 4.
Plus 4x minus 7x.
So yeah, that's the one that works. So it doesn't.
X equals 7 halves and x equals negative 2. And we're throwing out what? Negative 2. Because x has got to be greater than 3 halves.
I got lost.
Okay, we're going to move on. But if you want, I'll help you in just a minute. Okay, we'll back up to this one. But just so we can finish, let's go on. Deal?
Oh, yeah, you just pulled the 2. That's where it is.
You don't even need me. Okay, so what happens if we have multiple exponents? So like the other one, we had multiple logarithms and we used logarithmic properties. Here, we're going to use exponential properties. Okay? So the first thing, it says you got 2 to the 5x minus 1 equals 2 to the 2x plus 7. If my bases are same, then my powers are the same. That's the only way those two equations are equal. So yeah, so you just set those equal to one another. And the domain on exponential equations is all real numbers. So we don't have to worry about that. It's not limited by that having to be greater than 0.
3x. That would be 8. 8 thirds.
8/3. Good. So that one's not bad.
Oh, you have to multiply this one times 3. So
Okay.
3x plus 15.
But yeah, so we use this rule here that says if my bases are same, then my powers are the same. The problem is my bases aren't always the same. So in this case, I'm going to do a rewrite on this 8 so that I have a 2 for the base. So you have to think about 8. How could I write 8 so that its base is 2? 2 to the 3rd. So another way to write 8 is to call it 2 cubed to the 3x minus 2 equal to 2 to the x plus 5. I've almost got bases that are alike. Right? When I raise a power to a power, what's the rule? Multiply my powers. So now I'm going to take this 3 and I'm going to distribute it through that parentheses. So 2 to the 9x minus 6 equal to 2 to the x plus 5. Now I can say if my bases are equal, then my powers are equal.
So it'd be 8, and then that'd be 11. So, 8, 11.
So 8x equals 11. So x is 11/8. Is that what you said? Okay. Y'all see? Oh, I love this. It's a cool move. It's hard to imagine, but it's not bad. So how might we want to call 9 such that it and 27? See, it's really easy to think, I want to divide that 27 by 3. Wrong.
You're gonna multiply
You can
it.
take them both.
You have to take them both to 3. Good. So how would I rewrite 9 in a base 3? 3 squared to the 2x and 3 cubed to the x plus 2. Good. Good, good, good.
Is she slave driving y'all?
I am. I'm the worst.
So you would
So this is now 3 to the what trip?
what?
3 to the 4x,
Yeah.
right?
It'd be 3.
You're going to distribute equals 3 to the 3x plus 6. Now my bases are equal, so my powers are equal.
It'd be 6.
Y'all have a good one.
You two.
Yippee skippy.
Ooh.
This one.
Woo!
4 could be.
They saved the best one for last.
Can you square? Well, no, if you square that, it'll only be.
2.
No, it'd be cubed.
Or
1 half
negative,
cubed is 4.
Like 1 negative 1 half. But if you did that to the, that could be an exponent.
1
Wait,
half
what am I
cubed
doing?
is 4.
I don't know what I'm doing. Never mind. Like if the negative 2 could like flip it, but I don't think that what.
You just
Well,
raise the
negative
1 half to
If you
3.
did negative 1
It's not 3. There's not a 3 here.
Because if you put 4 to the exponent.
Well, if you raise 4 to negative 2, it'll give you 1 half.
Yes, if you raise 4 to negative 2, it'll give you 1 half.
I was trying to raise 1 half to 4.
If you raise 4 to the negative 2, that's how you get it to the bottom, right? So if I raise 4 to the negative 1 power, I get 1 over 4.
Negative 2.
But I need it to be a 2 because I need to take the square root of 4. I need the square root of 4 is 2.
Yeah, but I'm just confused now because, like, so when you do 4 to the negative 2, then wouldn't it be 1 over 4 cubed? So then 1/16.
1 over.
It'd be 4 squared.
4 squared. Why am I saying cubed? I don't even know.
Yeah, oh yeah, wouldn't you multiply?
Oh, I see what you're saying.
Yeah.
Yeah, so that wouldn't work.
So that's why I think it's negative 1 half because
Because then you'd
then
be
the 2
taking the
goes to
square
front and you're
root.
taking the square root of.
Yeah, Grayson's right.
Okay. I want the base to be half.
Mm-hmm.
Half to what power gives me 4?
3.
No.
What? 1
Half to what power gives me 4? So I want to move it to the top, so it's going to have to be negative.
So negative 2.
Negative
So
2.
we're doing negative 2.
So I was right.
So it's half to the negative 2 power to the x, right?
Negative 3 would just make it smaller.
3
1 half times 1
is
half.
there's an 8.
Yeah.
2 cubed is 8. There's no 3 here.
No.
No 3.
Because
No
1 half
3.
cubed is making it smaller, not
It's 1/8.
Yes.
Right. It's smaller.
Yeah.
Yeah. Do you see what we did here? I mean, I think that was a whole lot of scary.
I was thinking,
We're trying to get 4 to be in a base of 1 half.
yeah.
Yeah.
I was trying to like make it in half but not be in the place of yes. I don't know. It was weird.
So half to the 5x plus 7 is equal to half to the negative 2x.
Could be 3.
So 5x plus 7 is negative 2x.
So if you add, it should be 7. Oh, it's 1. No, it's negative 1.
That should set you guys up to do worksheet A and B.
Okay.
Okay, so Lord willing, this is what we're doing on a Monday. I wanted to look before you guys put up. Okay, I did this problem, this letter D, alternatively. Instead of trying to take 4 down to the base of 1 half, I brought the 1 half up to base 4. So what would I need to put the 1 half power in order for it to say, I actually brought it to base 2.
You need to flip it. So
Right, it need to flip. So let it be in base 2. So 2 to the negative 1 flips it. So 2 to the negative 1 to the 5x plus 7 is equal to, how would I write 4 in base 2?
2 to the 1.
2 to the 2 squared. 2 squared. I'm writing 4 as base 2. 2 squared is 4. Y'all see that? So now it's negative 5x minus 7 equal to 2x. And that feels, I don't know. I mean, it's yuck either way, but I kind of like the way I did it the second time. Okay, so 2 different options there. Oh, well, they're equivalent. Okay, so that'll get you through worksheet B. Like I said, goodness gracious and the creek don't rise. We get to finish this worksheet Monday. Okay?